Hey everyone, and welcome. Today we are diving into something that is absolutely fundamental for anyone in a support engineering role, HTTP status codes. We're going to decode these so you can build out your diagnostic toolkit and just solve those tricky web issues way faster.
We have all been there, right? You get that ticket, the one that just says, the website isn't working. No details, nothing. It's frustrating, and now it's on your plate. So where on earth do you even start?
Well, your first and honestly, your most powerful clue is always going to be the HTTP status code. You can think of it as the universal language of the web. It's the server's instant report card on what just happened with a request, and it is the single most critical starting point for any diagnosis.
Okay, so here's our game plan. We'll start with why these codes are your first clue. Then we'll look at the good stuff, the 2XX success codes, and the detours you'll see with 3XX redirects. After that, we're tackling the errors you deal with most, the 4XX client-side problems and the 5XX server-side messes. And we'll wrap it all up into a simple toolkit you can start using immediately.
So first up, let's lay the groundwork. Every single status code falls into one of 5 main categories. And just understanding these classes will unlock everything else for you.
So here they are. It all comes down to that first digit. Now, you won't see 1XX informational codes that often, but the other 4, you'll live and breathe these. 2XX means success, 3XX is a redirection, 4XX points to a client error, and 5XX points to a server error. Just knowing that much gives you a huge head start.
All right, let's start with the good news. The green lights. These are the 200 level codes, and they mean everything went according to plan. But, not all successes are created equal.
So let's look at the key differences here. A 200 OK, that's your standard, yep, it worked when you load a web page. But a 201 created is more specific. You'll see this after something like a user signing up. The server's not just saying, OK, it's saying, OK, I've created the thing you asked for. And then you've got 204 no content. This is also a success, but it's for when the server has nothing to send back, which is perfect for, say, a successful delete action.
Okay, moving on to the detours of the web, the 300 level codes. These are all about managing change, and they're super important for both users and for things like SEO. The 2 big ones you need to know are 301 and 302. A 301 moved permanently is like sending out a change of address card. You're telling browsers and search engines, hey, this page is moved for good. Update your bookmarks. A 302 found, on the other hand, is temporary. It's like saying, go here for now, but come back to the original address next time.
So redirects are usually helpful, right? They keep the web from breaking, but when do they turn into a full-blown user-facing problem? This is when. When they go wrong, you get that dreaded too many redirects error. This is a redirect loop. It could be something as simple as a misconfiguration in WordPress, or maybe some bad routing logic in a single-page app. A really common one is an HTTP to HTTPS loop, which often happens when a load balancer gets confused about the protocol.
All right, now for the 400s, client-side errors. When you see a 4XX code, the server is basically saying, hey, I'm working just fine. The problem is with the request you sent me. Now let's clear up the single most common point of confusion, 401 versus 403. A 401 unauthenticated actually means unauthenticated. The server is asking, who are you? It doesn't know the user's identity. In contrast, a 403 forbidden means the server knows who you are, you're logged in, but it's saying, sorry, you're not on the list. You don't have permission to see this.
So when you get a ticket like this, I'm logged in, but I can't get to the admin reports, a little alarm bell should go off in your head. That sounds exactly like a 403 forbidden. They've been authenticated, but they aren't authorized.
So what's your playbook for a 403? It's pretty straightforward. First, check that user's roles and permissions in your system. Then, look at any access control lists on that specific page or resource. And finally, check for bigger things, like a firewall or an IP block that might be getting in the way.
Here's another one you see all the time. Hey, the link in this email is broken. 9 times out of 10, you're looking at a 404. For a 404 not found, you start with the obvious. Is there a typo in the URL? Has the page been moved or deleted? If everything looks right, you might need to check the server's routing rules. And here's a pro tip. Sometimes, for security, a server will return a 404 instead of a 403 just to avoid even admitting that a sensitive page exists.
What about a ticket like this? A script or an API integration runs perfectly for a few minutes, and then suddenly, it gets blocked. This is a classic sign of rate limiting.
And that brings us to the 429 too many requests error. This isn't really a failure, it's a protection mechanism. The server's just saying, whoa, slow down there, you're hitting me too fast. And a well-behaved API will even include a retry after header to tell the script exactly when it's okay to try again. Okay, deep breath. We're moving on to the 500 level errors. This is where the script flips. The client sent a perfectly valid request, but our server just couldn't handle it. The problem is now on our end.
This is the kind of ticket that makes pagers go off. The whole site is down, or I'm just getting a generic error page. This is the telltale sign of a 500 level error. A 500 internal server error is the most generic error there is. It just means something broke unexpectedly. So the status code itself isn't the clue. Your first step every single time is to get into the server logs. That's where the real story is. Look for crashes, database errors, and always ask, was there a deployment recently? You'll also see 502s and 504s a lot with modern web apps. A 502 bad gateway means one server in the chain got a broken response from another server behind it. A 504 gateway timeout is different. It means the first server got no response at all. It just waited and eventually gave up. One points to a broken backend, the other to a slow or unresponsive one.
All right, let's wrap all of this up and build that toolkit I promised. This is the cheat sheet, the mental model you can take with you after this is over.
Just think of it like traffic lights. 200s are green. Did it work? 300s are yellow. Does this thing live somewhere else now? 400s are orange. Is the problem with the client's request? And the 500s are a big red light. Is the problem on our server? If you can answer that one key question, you already know exactly where to start looking. So I'll leave you with this thought. When you combine this knowledge with modern observability tools, you're not just closing tickets anymore. You are becoming the first line of defense for the health of your entire system. You're the one who can spot problems before they turn into major outages.